Welcome to Academic Guru's Tutoring Thursday, where we answer all of your high school, college, and university questions. If you would like your question to be featured on next week's Tutoring Thursday, please submit your questions to questions@academicgurusinc.com. Don't forget to subscribe so you can stay current with all of our new videos.
Hello everyone. Today I'm going to be talking about Kirchhoff's rules and basically the misunderstandings that usually I find students are having about the two rules of, current and voltage rule. And basically we're going to talk about that. We're going to, do an example and implement what we will be learning in that example, and then hopefully it all clears up all the misunderstandings and all from you guys. All right, so basically this Kirchhoff's rules are coming into play when we're dealing with circuits. So we are having a bunch of resistors all wired up together. We're maybe like 1, 2, or 3, or however many batteries, and these are all wired up, and then we're usually asked, what is the current in each branch, or like what is the if we have one of the currents, what is the, R3 resistor R3 and things like that. So these two rules are basically expressed they're given as current and voltage rule, and what they are is that basically one of them respects the fact that we are having conservation of charge in a circuit. So in a closed loop, what Kirchhoff's rule says is that if I'm having a closed loop and I have a current passing through this loop, the current rule basically says that the amount of current that gets into a point, like a junction point, is equal to the amount of current that's coming out of it. Let's say, let's just denote I1, I2, I3, and they all get into this point somewhere in the circuit, and what comes out is I4 and I5, and what this says is that I that gets into the circuit is equal to the I that comes out of the circuit. So basically what it means is that I1 plus I2 plus I3 is equal to I4 plus I5. So very simple. It's very intuitive also, because it just says that we need to respect the fact that we have conservation of charge. If these amount of carriers of charge get into this junction, nothing more or less should come out of it. That's literally what it is. So there is really no misunderstanding about this rule really, but the problem becomes a little bit more pronounced when we introduce voltage rule to students. So what they say, basically what this voltage rule says is that if we are having a circuit, as you can see, for example, here, if we're having a circuit, it says if we go in a closed loop, so whatever loop you want to find, like if you want to take this one or this big one, whichever you like, what this voltage rule says is that it says you take a closed loop, and the amount of voltage that you spend, basically the amount of, so to speak, energy that you spend to go around this loop has to be adding to 0. It is also very, very intuitive. It just says this is like literally conservation of energy. You can't just have after you come out of this battery and then you get back to this negative terminal of the battery. You can't have more or less amount of energy. You basically deplete the whole energy, and that's why the battery is sitting here. And that's the task of a battery. So So hopefully that just makes it a little bit more meaningful. But let's just apply these two rules in an example. Let's just keep this as an example, and let's just apply all these rules that I told you, like the current rule and the voltage rule in this example, and see how these actually work out, and how we can justify the negatives that we use, the positives that we use, all that sort of stuff.
Thank you for tuning into our Tutoring Thursday channel. If you enjoyed watching this video and found it helpful, please give us a thumbs up, comment, and subscribe. We would love to hear from you. Until next week's Tutoring Thursday, happy studying.